So we took a look at air masses. When air sits over a place for a long time, it takes on the characteristics of that place. If it sits over the poles, it gets cold. If it sits over the tropics, it gets warm. If it sits over the ocean, it picks up moisture. If it sits over land, it dries out. And we combine those two to get maritime polar, continental polar, maritime tropical, and continental tropical. When those air masses move, they don't mix with the air that's there already. Instead, they fight it out with them. And that's where the action is at in weather. And so we'll take a look at a couple of different situations. The first is when cold air is moving in. When cold air moves in, then we call it a cold front. Cold air is more dense. So we have cold air, maybe 60-degree air moving in where the air was warm and moist. 75 degrees maybe. Imagine a 4th of July day in the summer. In the winter, obviously, these temperatures would be different. And cold fronts aren't as big a deal in the winter as they are in the summer. That warm, moist air has energy in it. And actually, the bigger the difference between the warm air and the cold air, the bigger temperature difference, the stronger the cold front will be. So this cold air is more dense. The warm air, when it comes, this is the cold air moving in, the warm air just gets out of the way. It rises, and when it rises, it cools off and forms water droplets. But the crazy thing about water is, remember, it took energy to evaporate this water out of, say, Lake Superior. To change from a liquid to a gas, you have to put energy in. When that water vapor turns back to a liquid, it gives off that heat. And that makes the air rise even more. In fact, it rises above the freezing line, and it may freeze into ice pellets. If it was a water droplet and it freezes, it becomes an ice pellet. Snowflakes form a little differently. So we have this big, massive cloud that builds up right at the front. This would be like ground level. Here's a tree. This big, massive cloud forms right at the front where the warm air rises and condenses. We call this a cumulonimbus cloud. Cumulo refers to puffy, nimbus refers to it's raining out of it. It's got rain, it's got hail. These ice pellets falling down through the cloud strip electrons, and they pile up at the bottom, and then a spark jumps. So this is where we're going to have lightning, and of course lightning creates thunder. We have winds out of the probably southeast on this side, and winds out of the northwest on this side. That's going to create a wind shear. Sometimes, if we have wind shear and we have uplift like that, sometimes it can spin up a tornado. So we've got a heavy precipitation. This is a brief period, may only be 30 minutes long, but it's going to be a brief period of intense weather, heavy downpours, maybe hail, maybe thunder and lightning, possibly even a tornado. This is going to be the severe weather warnings in the summer along that line. Now this moves through quickly. The whole front moves about 30 miles per hour. So it would cross the Upper Peninsula maybe in, 8 hours maybe. So it hits hard, it doesn't last long. We went from warm, moist air and sunny skies ahead of the front to rapidly building clouds. It poured down rain, maybe severe weather, and then after the front goes by, we're in 60-degree weather, 60-degree temperatures, northwest winds, kind of gusty, but the sun comes out. And it's all over. It's a very fast-moving storm system. On a weather map, we draw it with a shark's tooth. That shows it's aggressive, it's dangerous, the teeth are sharp. That's a cold front.